Good day, everyone. I am going to discuss about the topics for the first week of quarter one in the most essential learning competencies in Mathematics 7. Okay, so we have sets and set operations for week 1. Now, we are going to start with the introduction to sets. Before we have the lesson, we should be guided by the objectives that we're going to achieve at the end of watching this video lesson. First, you should be able to define and then identify a set. Next, you should be able to determine the cardinality of the set. And last, you should be able to describe a set using roster method and set builder notation. So let's get started. I have here 3 pictures and I want you to look at each picture. So as you can see, the one at the left side is a collection of clothes. The one at the upper right is a collection of shoes, while the one at the bottom right are things that we use in math class. Can you say now what you notice with the following pictures? You're right. They are all sets or groups. When we take the meaning of this in general, using the terms in general, we may say they are just sets or groups. We used to have this, we are used to these words to mean the same thing. But take note, in mathematics, when we say sets, this differ from groups. Why? Let's see. Set is a well-defined collection of objects or things. But for groups, it's just merely a collection. For set in mathematics, we say well-defined. We have here well-defined. It has to be a well-defined collection. When we say well-defined, it means it's specific. The definition must not vary from one person to another. So it has a unique or specific definition. Of objects or things, collection of objects or things. Now, what do we call these objects or things that are found in the set? We call them elements. Yes, they are elements. And elements are denoted by an epsilon. It's a Greek letter in the Greek alphabet, and we read this as element of. An element of or belongs to. Okay, so let's take this example. Let A be the set of days in a week. Take note, days in a week. I am pretty sure that everyone is familiar with the days in a week. But before we have that, let's give emphasis first on this A. A is the name for the set of days in a week. So we start with writing the name of the set. Take note, a single capital letter is used to name a set, and it will be followed by equal sign, and then next would be the open curly braces. Now we could start enumerating the days of the week. We have Monday, Tuesday, Wednesday, Thursday, Friday, up until Sunday. Take note, this is set A. Now, as you notice, Monday is a day of the week. It's a fact that Monday is a day of the week. Therefore, we could say that Monday belongs to set A. Or maybe Monday is an element of set A. Since we already know how to represent or how to denote elements, and we use an epsilon, we write Monday, then the epsilon, and followed by the name of the set, which is A. We read this as Monday is an element of set A, or Monday belongs to set A. If you want to start from A, you could also say set A contains Monday. Okay? Now, from the given set, we check also on the elements that are contained in this set. So we started from Monday and end up to Sunday. And how many days do we have there in a week? Yes, we have 7. we have 7 days in the week, and it follows that we could also say that we have 7 elements for this set. We write A has 7 elements. Okay? 7 elements. So this can also be simplified using the notation and symbols. When we count the number of elements in a set, we refer to the cardinality of it. Cardinality. When we say, when we represent or when we denote cardinality, we use a small letter n. And we enclose the name of the set with parentheses. So we write n, open parenthesis A, equals, close parenthesis equals 7. We read this as the cardinality of set A is 7, or set A has 7 elements. Okay? That's now, since we can determine the exact number or the cardinality of the given set, we can identify that set as finite set, because from the definition it says here a finite set has countable. When we say countable, it has I mean, you can count the number of elements. You can determine the cardinality. Okay? Next, example 2. Let B be the set of even numbers. So this time, even numbers. So let's recall what even numbers are. Even numbers are numbers which are divisible by 2. So we have the name of the set. Let's start from that. And then the equal sign, open brace. And we start from 2, followed by 4, 6, 8, 10, 12, and it's never ending. So we use ellipsis and a close brace. This time, since we have 3 dots there, or ellipsis, this denotes that it's never ending. Therefore, it has no end. The cardinality cannot be determined. Now, if a set has a cardinality that cannot be determined, we call that as infinite set. So we say that B is an example of an infinite set. It has an infinite number of elements, or we could say that the elements cannot be counted. Okay, let's proceed to the next one. Now, how do we represent sets? Sets can be represented using the roster method, where the elements are listed, separated by comma, and enclosed by curly braces. So if we are going to analyze this definition, it only implies that we have used this already before in the previous examples. Yes, because it is commonly used in representing sets. So let's take this example as the set of days in a week. So we have A. As you can see, all elements are enumerated or are listed, and between the elements is a comma, and everything is enclosed by braces. So we met the definition stated there for roster method. Now, aside from the roster method, do we have another one? Yes. The second one is what we call the set builder notation. Actually, this is under the rule method. But instead of focusing on that, because they just mean the same thing, it's just that set builder notation is following a certain format, and the format goes like this. Okay? Now, how do we read this? It's it's a common problem among the students. They do not know how to read this. Okay? So as again, this braces is read as set of all. Okay, because we start from reading the set of all and then followed by x. So we say of all x. And then this vertical line here, the vertical line, is read as such that. and it will just continue. Okay, and it will just continue. Okay, so let's have an example. So suppose here you're given, okay, so we have again same set, set A. We write this in set builder notation. We have A equals or is the set of all x such that x, this x here refers to the element, every element of the set. So every, we mean one. Therefore, we use the singular form of the verb. Is a day of the week. You can write it like that. Sorry for the penmanship. And close brace. There you have it. A is a set of all x such that x is a day of the week. That's it. Now, example 3. We are going to discuss about the factors of 18. Do you still remember the factors of 18? Huh? Okay, let's see. When we say 18, okay, sorry. Say 18, we have 1 and 18, 2 and 9, 3 and 6. So we only have 3 pairs. Okay, so we use the roster method. It says in the roster method, we are going to list down the elements. So since we're dealing with numbers, we follow the increasing order. So 1, 2, 3, 6, 9, and 18. And there you have it. Okay? Next, we use the set builder notation. So, set builder means we are going to state the rule, what's common among the elements of the given set. So we have C is the set of all x such that x is a factor of 18. And that's it. Okay, let's now have a practice. Since you already know when will you identify a collection or a group as set or not, let's just have it. So determine whether each of the following is a set or not a set. First one, intelligent students in your section. Is it a set or not a set? Okay. Students who stand above 5 feet in your grade level. Is it a set or not a set? And the third one, counting numbers between 4 and 13. So let's have it. The first one is not a set simply because the word intelligent, the modifier intelligent, may have a number of definitions. You have different meanings. It is not specific. So that make this given not a set. Next, who stand above 5 feet. So there is a part of the given condition that states about the specific definition. So we can identify the elements of for this set because it has a specific definition. Those who stand above 5 feet. Okay, and so it's a set. And for the third one is counting numbers between 4 and 13 set also because we know what counting numbers are. Counting numbers are the one you use for counting. So when we say between 4 and 13 are not excluded. So we have 5, 6, 7, up to 12. Okay? And enclosed by braces. There you have it. Okay, let's have some practice on the following. Write the following in roster notation. The first one is letters in the word resilience. So we all know that we just have to identify the letters in the word resilience, and we are not going to have a repetition of such letters. So we have R, E, S, I, L. We already have an I, an E, then we have an N, and C. And there you have the letters in the word resilience. Next would be prime factors of 24.
So we already know the definition of prime numbers, and we just have to take the prime factors of 24 only, starting off with 2, 3, and that's it. Nothing's followed. Okay? So we just have to omit or erase this comma. 2 and 3. Okay? Next, we have the set of x such that x is an integer between 5 and 10. So we are going to start from 6, then 7, 8, until 9. And there you have it. That's it. Let's proceed to the next. This one, we are going to have these sets in set builder notation. Take note, it must follow the format set of all x such that x has a property p. So here, in the first example, we have the set of 4, 8, 12, 16, and so on and so forth. So you will notice that these are multiples of 4. So we write, it is the set of all x such that x is a multiple of 4. Okay, and there you have it, close brace. For the second one, inside the braces are Bubbles, Buttercup, and Blossom. So for most of the girls, I think you are familiar with these characters. Yes, they are characters in the Powerpuff. So Powerpuff Girls. So we have the set of all X such that X is can have one of the Powerpuff Girls. Okay, Powerpuff Girls. Can have it like that. Okay, the idea is there. Powerpuff Girls. And the last would be the set of 1, 3, 5, 7, 9, 11, 13. So what do we notice in these numbers? They are odd. But take note that the last element is identified and it's 13. So it means there's a limit. So we could just simply have set of all x such that x is, and you can also say 2, you have 2, 4, 6, 7 is 1 of the first 7. You can have that. The first 7 odd number. First, okay, I'll add first 7 odd number. Numbers. And there you have it. Okay? So I hope that you learned from it, and that would be all for this today. Goodbye, guys. See you next time.